All right, let's finish this up. We don't really have very much to go. So I'm on the bottom of page 456. And on 456 and 457, they talk about abstract classes. When a class is abstract, it's too general to be instantiated. So for instance, an animal is too general for you to make an animal object. All right? That kind of thing. If you had a vehicle class, a vehicle itself, and underneath it maybe you have cars and trucks and whatever. All right, but a vehicle class itself would be called abstract because it is too general to be instantiated or to have objects made of it. And that's what it says. It says, creating classes can become easier after you understand inheritance. All right? When you create a child class, it has all the general attributes you need. You only have to add the new stuff. Fine. But when you have a class that is so general, all right, that you can't make an object from it, it's called abstract. When you've got a class that's not general. So for instance, I might not be able to make a dog object, but I could make a St. Bernard object. All right? Classes in which you can instantiate, they're called concrete classes. All right, so a concrete class and an abstract class, the difference between them is you cannot make an instance of an abstract class. You can't new it, so to speak, where you can with a concrete class. And that's what they talk about in here. So when you make a class abstract, notice you use the word abstract. All right, they can be public. They doesn't show it in here, but they can be public, private, etc. But you need the word abstract. When you create abstract classes, please look up on the screen here. They can hold either regular methods like this, or they can hold abstract methods. An abstract method has an access specifier, public, private, or protected. The word abstract, the return type, the name, then in parentheses, either some arguments or no arguments. But notice there's no body. All right? What an abstract method is it is the equivalent of a contract. And it says, hey, if I go and inherit from animal, I agree that I will make my own speak class in there. And it has to return a string. But again, as we talked about in an earlier class period, if you tell a dog to speak, it'll do it differently than a cat. That'll do it differently than a bird. All right? So again, an abstract class cannot be instantiated. If you add an abstract method to a class, the class must be abstract. So only abstract classes can hold abstract methods. All right? And that's pretty much the gist of what you get if you read 456 and 457. Then again, they show you the example here on 458. And when you have these abstract methods, what do? Come on. Well, if you look here, you override what's in there. That's what will end up happening. So if I look here, I guess I went up a page too much. But if I look on the bottom of this page here, the bottom of page 458, notice when I want to use the speak method for a dog, I have to override it. When I want to use the speak method for a cat, I have to override it. All right, what am I overriding? I'm overriding where it is in the abstract class. So I make it do what I want it to do. Right. It's not maybe the greatest explanation, but I can't think of a better one to give you, to be honest with you. So again, the system is smart enough that when you look on the screen here, and this is what, the middle of page 459, it knows that Spot is a dog. So when it tells Spot to speak, it'll have Spot say whatever you said a dog would say. It knows that Puff is a cat. So when you tell Puff to speak, It will say only what you program a cat to say. All right? And that is the idea of using something abstract. Classes can be abstract, methods can be abstract. All right? But again, if you make one or more methods in your class abstract, the class itself must be made abstract. All right? Now, I'm going to go back to something that it isn't exactly what he said, but kind of that Christian asked about before. All right? And that's the idea. Let's say that I've got this. Okay, so this is not going to be a good example, but it's the one that came up to me. I actually saw a thing online, and you never know when you read something on Facebook if it's true or not, but they called it, what was it, a donkey, where a zebra had mated with a donkey, and it looked like both of them. All right? Okay, but the point is, that's how it works in regular inheritance, right? So if I have a donkey here, okay, I think I spelled that right, and I have a zebra here, I don't care if we call it a zeki or a donk, whatever it is. Let's call it a donzeb. All right? But you look at that and you know that that child has two parents. You can't do that in this programming language. When you create a child, children can only have one direct parent. They cannot have two. What you get when you do this is you get what's called the diamond effect. So if you had another one up here, whatever it is, it sort of starts to resemble a baseball diamond or an actual diamond. That's where it got its name from. Not from the baseball diamond, I think from jewelry. All right? But you can't do that. Okay? So you're like, okay, why is that a big thing? Well, what if I wanted to get some stuff from here and I wanted to get some stuff from there? I can't do it directly by having two different classes, but I can create something called an interface. So, again, just so you hear the terminology, C#, like a lot of other languages, supports what's called single inheritance only, meaning one parent. But it supports multiple interfaces. So the way you get around this, that picture that I showed you, is you use what are called interfaces. All right. So what's an interface? It's like a class, but it's not as powerful as a class. You can't instantiate it like it's abstract, but it's not a class. It's just a bunch of stuff that people can inherit from, for lack of better words. So if we look starting on the bottom of page 460, and it goes on to 461, 462, 463, and 464, that's what they're talking about. All right, and they mention C++, not C#, but C++ is an example of a language that allows that diamond effect. It allows multiple inheritance. All right, C# does not. So again, the way you get around that is you use what's called an interface. And Java works exactly the same way here that C# does. There's really no difference. All right? Java supports interfaces. Java supports single inheritance. All right? So it says C# does provide an alternative to multiple inheritance known as an interface. An interface is a collection of methods that can be used by any class as long as that class overrides it. All right, I mean, I've heard this called like a class minus, where it's not really a class, you know, but it acts like one. When you create an interface, by and large, it's just convention. You always start an interface with the capital letter I. So when people see that, you should never start a class with a capital I. Because when people see something that starts with an I, they assume it's an interface. All right, that's like an unwritten rule. Doesn't mean you can't break it, but it means you should break it. So what this means is anybody who Now, we talked about when you inherit, it's that colon, and it means it's a parent. You use the colon for this too, all right? So you can have colon, one class, but as many interfaces as you want to. You're going to see that in just a second. So anyone who implements this interface has to have a method called work, and it must return a string. That's all it means. All right? And again, you're going to see an example of this in just a second. So notice we've got a class here. And notice we've got the colon. This doesn't mean this inherits from this. It means this implements this. All right? So anything that's defined inside of iWorkable, employee must implement. Again, I'm not even saying, does that make sense? Hopefully it does. And if it doesn't, I tell you, read the book. I don't even remember in the example I gave you if I put in an interface or not. I'll have to go back and check. So the author says here, and this is one of the better parts of the chapter, on 464, it's like, okay, we just threw a whole bunch of stuff at you. So when do you use an abstract class and when do you use an interface? So on the top of page 464, the author tries to tell you, in generalities, when you use one as opposed to when you use another or the other. It says typically you create an abstract class when you want to provide some data or methods that the derived class can inherit, but you want the subclasses to override specific methods. Otherwise, you make it an interface. The bottom line is this. How do you know which one to use? It's something that you learn over time. And here is one place where I wish the author at the end of the chapter would have added another one of her you-do-its, but she didn't. All right? So, the last thing that's discussed in here, I guess there's two things. But the second last thing that's discussed in here, starting on page 465, are extension methods. With an extension methods, that's fairly new. It was introduced in C# 3.0. So it's only, I don't remember when 3.0 started. I think they're in 7.0 now. All right, so it's been a few years. But it's like if you ever said to yourself, you know what, I really wish that this class that's built into the C# programming language, I wish it had this. I don't really want to make my own class. I'd like to use their class, but add something to it. That's what an extension method is. It's when you can go and add something to a class that's already been created. All right. If you don't want to allow that to happen, you can put the word sealed in before your class. All right. Most people don't even use these. This is a very advanced topic. It's not going to be on your test, I don't think, or anyplace else. But all they're showing you here is that there may be a reason that you want to use it, that you want to add something to something that already exists. All right? Leave it at that. All right, and the last thing she does talk about in the chapter, starting on the bottom of page 467, is how to work with all this stuff with GUIs. You may have noticed that virtually everything we've been doing lately has been console. You can do this with GUIs. All right? And is it easier? Is it harder? It's different. But you can do it with GUIs. We could set it up. So, for instance, you know, on the last program that you did, or the last test that you took, all right, we could have set that all up so I had you do that and basically set it all up so that that bank account was in a GUI. We could have done that. And then when you click the button to say create an object, it could have gone through, and it could have actually gone through and ran those same kind of validate routines. And if it worked, we could have added it to a list or to an array or whatever. Typically, the reason most of it's done, and it's done without GUIs, is this stuff is not graphical when you create this. All right, so there's really no reason to make it a GUI. You tend to have better, more straightforward code when you create it and it's not a GUI. All right, and that is it for the chapter. Now, during the break, I handed you out this. Let's first go through this. We'll do it a little bit out of order. And again, this is pretty much the test that you will take Monday of next week, whatever day Monday is. The 4th, I think. All right. So you should know what a superclass is. So if you've got two classes and you've got employee and commission employee, employee would be the superclass. All right. Why use information hiding with OOP? You use information hiding so people are able to use things without knowing how they work. All right. And I've talked about this before. I've given you the example where I showed you a calculator. What you see is the interface. How the calculator figures out something is the implementation. The implementation is typically hidden from you. All you see is the interface. All right. Number 2, a base class is another word for a parent class. A derived class is another name for a child class. The toString method, yeah, it can be used as a debugging aid, but what it can do is you can override the toString method like we did on our last test, so that when we said write line followed by the name of the object, it printed out what we wanted to print out. All right. The equals method can determine if one object is equal to another object. All right. Again, I said this before, one way of describing inheritance is an is-a or is-an relationship. 2 other words for derived class are subclass and child class. Another word for base class, 2 other words really, would be parent class. Sometimes it could be a concrete class too. What is protected data? Protected data is available. All right, by default, protected data is available to all descendants of a class. A fragile class, as it says, is a class that depends on field names from parent classes. Overwriting is rewriting something. Typically, you've got a child class that overrides or rewrites a method so it does it different than the parent does. A base class member that is not hidden is visible in the derived class. Remember, if something is implicit, the software does it. So notice when you do, C# makes an implicit conversion. So the software is doing it. Every class in C# derives from the object. Object is the top of the chain, so to speak. It says, what is a fingerprint for an object What is a fingerprint for an object? Because it uniquely identifies the object. That's a hash code. This, if you look on here, what? 1, 2, 3, 4. This is 5 questions on the test. Number 11. All right. What does base mean? What is an abstract class? What is inheritance? What is multiple inheritance? And what are ancestors? All right. That'd be one you'd probably want to really take a good look at. A virtual method, as it says, is one that can be overridden by a method with the same signature in a child. An extension method is a method that can be added to any type. So you can add it to things that already exist. As far as the terminology, as you can see right here, you should know what an extended class is. Again, as I mentioned, also known as a derived class, a superclass, which is the same, as it says, it's a synonym for a base class. You should know what protected members are and what protected is, what polymorphism is, system.object, get type, reference, equality, equals, and a sealed class. So again, that test will be next Monday, the 4th. So when you come in here, that's the only thing that will be scheduled when you come in here Monday of next week.